Who in this room knows how to write a SQL select statement? Okay, it's like 60%. It's definitely more than half, but it's also not like 90%. Who here has been either is aware of or has been sold to by a sales rep from Snowflake? Okay, some, not as many, but still a lot. Anybody who's written a select statement, this is a presentation for you. Anybody who has been sold to by Snowflake, this is really a presentation for you. My name's Tristan. I run a company called Fishtown Analytics. We make a product called DBT. DBT is Apache 2 open source, and there's a managed layer on top of it that's in the cloud. There are 17 of us. We're based in Philly, and we're bootstrapped to date. There are about 1,000 companies, just shy of 1,000 companies that use DBT in production today. And my daughter goes to daycare and brings me home all of her germs. This is a story of an industry shift. If anyone's in the data space, or in the analytics space, you are probably aware of the shift that started in 2012, 2013 with Redshift. Redshift was the first big cloud data warehouse, and or first like high-performing, cheap cloud data warehouse, and it started. It was the first big one. Now there's BigQuery. Now there's Snowflake. If we drink a beer afterwards, I'm happy to tell you what I think about all those three products. But my official stance is they're all fantastic. They really unlock a really significantly new workflow for how to do analytics. There's a whole set of companies that have been founded on top of the power of this platform. Looker just sold to Google for $2.6 billion. The entire reason that Looker is successful, aside from the fact that they have a fantastic team and all of that, but they were the right product for the right ecosystem. Really, they grew along with Redshift, and they took advantage of all the power there. The thing that is happening in this space is that there is a shift from ETL, extract your data, transform it in some intermediate layer in a language like Python, using frameworks like Hadoop, and then loading it into the final destination. We're seeing a shift towards loading the data directly into the data warehouse, extract, load, and then transform after the fact. And these are the kinds of logos that you see of the companies that do this stuff. DBT is the T in this ELT stack. It is, I believe, and please contradict me if you have data to the contrary, but I believe we are actually the largest T player in this market today, which is not too bad with 17 people. The benefits of open source distribution. So this is what the T actually looks like. You can see, and this is a lot of screens. I don't know whether I should look this way or this way. The ingestion happens over on the left-hand side of this diagram, and then everything happens in the data warehouse. The data warehouse is kind of the substrate that all this happens on top of. You first snapshot the data so that your mutable tables, you get version-controlled or immutable versions of those tables. You transform the data into a shape that will actually be useful for analysis, whether that's with Looker or Tableau or whatever. You run tests on top of it. What a novel concept from software engineering. You should actually test all of this complicated transformation code. You deploy it using mature CI/CD pipelines, and then you have inbuilt documentation that runs on top of all that. And so that is what we think of as a modern way to do data transformation, to do what we call analytics engineering. And the main reason that we call this analytics engineering and not data engineering is that we think that data analysts should do it. There's a lot of ways that you can transform data. You can write scripts, you can spin up Databricks and write PySpark jobs. There's a ton of ways that you can do this. DBT is the best way for data analysts to own this workflow. There's maybe 50,000, maybe 100,000 data engineers in the universe. And there are between 1 and 5 million data analysts. And so DBT is a tool to let data analysts own that workflow. They know the business better, they know the data better, they just are the natural ones to do this work. So I'm gonna show you the product, and I'm gonna do a really silly thing and show you an alpha version of an interface, and I'm gonna show it to you live. And so we'll see how that goes. So this is all data processing really happens in a data structure called a DAG, directed acyclic graph. DBT allows data analysts who might not even know what the heck a DAG is to construct really sophisticated DAGs. And this is actually, I mentioned we're open source. We have a very quickly growing community in Slack. It looks like that. There's about 3,200 people in there now, and it's very active. We have we spend a lot of time answering questions on there. So we actually ingest that Slack data into Snowflake. We then do analysis on top of it to actually make sure that we have metrics. So like, how long is it before somebody posts a question and gets a reply? What's the weekly active users? That kind of stuff. We want to know that our community is healthy. And so these nodes over here on the left are actually the source data tables. So all this is coming from three different inbound tables ingested into Snowflake. And then there's this series of data transformations, and all of these are stacked one on top of another, and eventually get to this final table called fact Slack posts. And the term, the fact nomenclature is from Kimball's style star schema data modeling, if any of you have done any of that stuff before. So this is kind of this is the visualization that DBT provides that is on top of all of your code. You can click View Documentation and dig into there. You can see the code. If I really had created a great demo, I would have actually written documentation on top of this. So this is the consumption interface. This is if you were a data analyst and you wanted to share with your team and say these are the tables that I've published for you to analyze, you'd share this interface with them. As the data analyst, you are actually editing code in this interface. And this is that same model that we were just looking at. The main point I want to make here is that this is all SQL. If you know how to write a select statement, you know how to write DBT code. There is just a little bit of templating that is on top of this SQL, and this is where the DBT magic comes in. So DBT, you write code in the native SQL dialect of your database, in this case Snowflake, and then you layer on top of that Jinja, which is a templating language that's very common in the Python ecosystem, and there are functions in DBT's Jinja that allow you to do things like reference other models. Let me just hit plus a couple times and see if that, yeah, okay. This ref function references another model, and it is actually this, which looks very idiomatic to SQL, right? I'm just like saying, selected from this other reference table. But that's all DBT needs in order to actually build this graph. And really, we were just looking at a subset of this graph here. The total project looks more like that. And so that's the type of data application that, and this is like our internal project. This is a very limited project. This has maybe 100 transformations in it. WeWork has over 1,000 transformations. There's like a large number of companies that are in the like 1,000+ range. And so you start with a select statement that actually expresses your business logic. You can see here we're actually taking two tables, we're left joining from one to another, and we're saying we only want to include records that have this one particular flag set, and we output the data at the end of that. And the DBT understands how to take that select statement and materialize that in the database as a table or a view or an incrementally built table. And so you see up top here, config materialized equals table. that's going to tell DBT to actually take the results of this query, materialize it in the database as a table, so that it'll be available and fast for the downstream consumption in Looker, Tableau, whatever. I think that I'm honestly good there. That was like really honestly the fastest overview of DBT that I've ever done before. And normally I'm doing these in like hour-long deep dive calls. But please, here's my ask. We have a fast-growing community, and anybody in this room who understood any of the things that I just said, we'd love to have you as a part of that community. Download, try it out, ask me questions afterwards. I'm happy to also get on a sales call with you, but really like the thing that we're interested in is growing the open source community today. Thanks, everybody.
For this group, how do you make money?
That's a great question. It started off as a traditional open source play of training and services. And we now have our managed software. The actual thing that you're seeing right here is a management layer on top of the core open source product. So we charge, it's a SaaS product. You look like you're not convinced. We do on-prem, yeah. We can we do on-prem, like in your VPC.
That's not on-prem, right?
That's fair.
More questions? Yeah, go for it.
I'm just curious, how do you guys handle replication and clustering, just in case of like fault tolerance or not high availability?
Yeah, great question. How do we handle fault tolerance, other types of database level concerns? We don't. We are not a database. We do not want to be a database. The innovation that we are built on top of is the fantastic cloud data warehouses that exist out there right now. So the real question is, how does Redshift or Snowflake or BigQuery manage those types of features? We just sit on top of them. The big question today in how do you construct a data team is not that every business user currently has the capability of doing literally everything. 5 years ago, you had to write scalding or MapReduce jobs in order to access the kind of data that analysts are now accessing via SQL. So we're like moving up the stack. It used to be that there would be this small team of data engineers. If you had a company of 500 people, there might be 3 or 4 of them that if you needed a table built because you're a Tableau user, you would go to those folks and you would wait in line for 3 months until you get your table built. So now we're bringing that type of functionality to the larger data team. So now instead of that 3-person data eng team, it can be the 25-person whole data team. So the lines are they're shorter. But if you are not the kind of person who knows SQL, wants to know SQL, you're more comfortable in a Tableau interface, you're still going to have your partner on the data team that you work with. It's just that you're not going to have to wait as long to get that as you used to.
So the test part that you highlighted is fascinating, because that is where most people fail, because they assume it all works and then they find out they garbage data later. So can you elaborate on what you're doing to help that?
Yeah, there is a conference called Data Council that's coming up in like 2 weeks in New York. We were lucky to go to when it was called Data Eng Conf back in like 2015, and we heard a presentation by, I think it was Microsoft, where they said, we do data unit testing by just writing assertions on top of data where the success condition is returning 0 rows. So you just express the logic in SQL, and if your test passes, it means it returns 0 rows. And if it returns any rows at all, those are the error rows. And so that's what we built. We were like, that's a fantastic idea. We're going to build that into our product. So now the DBT has very, concise YAML files that allow you to express rules about your data. and then you hit DBT test, and it goes through and runs however many, hundreds, thousands of tests against all of your underlying transformations, and it, consolidates that success failure message to you and shows you what's broken. I cannot imagine living in a world, living in a world without that is like living in a world without unit testing on top of application code today. Like, it doesn't make any sense.
All right.
Thanks, everybody.